Welcome to Science Central. My name is Gary. Today we are going to be looking at Newton's laws of motion. Newton's laws basically state, 1, an object in motion will stay in motion unless it's acted upon by an outside force. So if I was in outer space and I had a nice rock and I threw it, that rock would keep moving indefinitely until it ran into something else or another outside force worked on it. As it also states that if an object in rest stays at rest, so if I wanted to stay right here and not move, I wouldn't move until an outside force acted upon me. One of my coworkers came around and pushed me, or I decided to go out for pizza. The second law of motion is force equals mass times acceleration. This gives you an idea on how fast an object is moving and the force that it takes to put an object into motion. Today, we're going to be looking at Newton's third law. For every action, there is an equal and opposite reaction. And for that, we're going to use some new Newton cars that we have down here and some tracks that we made here at Science Central to kind of show how this action and reaction work. Let me throw on a quick lab coat here. And let's get started with our experiment. So for this experiment, we have 3 tracks set up because I have 3 different masses that I want to use so we can look at this theory. The way this is going to work is I have a mass or a film canister filled with weight. This is a 50-gram mass. We have a cart, which is right here, which is going to sit inside of our track, which is lined with little tiny straws that our car is going to roll across as it moves. We have a ruler or a meter stick attached here so we can see exactly the distance that our car is going to move. So let me show you how these cars work. First, we're going to take a small orthodontic rubber band and we are going to wrap it around a larger rubber band. Tricky there. We'll set it up on our cart. So this is basically going to work like a small slingshot. So we are going to take our mass, which will be in rest, give it some force and acceleration, and cause the mass to move one way and the car to move the other. So we will be doing some cutting, and we always remember safety first in science. So I'm going to place my goggles on, and I'm just going to give you a quick demonstration. Our mass should actually move, and when I cut this small rubber band, the weight is going to move one way, our car should move another way. It's not going to move very far right at the moment because we are not on the straw track, but you'll get the idea of how this cart is supposed to work. Obviously, our weight went one way. As I said, our cart didn't move due to friction, but you can see what's going to happen on our larger carts. So let's set up our carts. Our cart with our 25 grams back here at 0. Our cart here with 50, tucked right in there with the back of the cart at 0. Note we have our red flags up here so you can see it a little bit easier inside of our tracks. And our 100-gram car. So let's start with our 25. Our 50. And our 100. So, as you can see, the heavier the weight allowed the car to move a lot further. So, for every action, the mass moving one way, there is an equal and opposite reaction of the cart moving the opposite way. So, thank you for joining us for our quick review of Newton's laws of motion, and have a fun day. And remember, science is fun.